Welcome in everybody to another lesson. Today we are going to talk about some properties of addition and multiplication that are going to help you as you get further into your studies here. So let's see here. We're first going to talk about the commutative property of addition. So the commutative property of addition states that if you have any two numbers, for example a plus b, you can rearrange it to say b plus a. You'll get the same result. Commutative, you could think of it like the numbers commute. They move around. That's how you can remember the commutative property. So, for example, we have 5 plus 3, right? 5 plus 3, well, that's also equal to 3 plus 5. Because 5 plus 3 is 8, 3 plus 5 is also 8, therefore it checks out. So 5 plus 3 is the same as 3 plus 5 by the commutative property. Or let's say you had 27 plus 2. Well, that would be the same as 2 plus 27. You would get the same result either way. The numbers just move around, they commute. You can do that with addition. So just know you can do that with addition. Now, a big question that's asked is, can you do it with subtraction? So let's see here. Let's say you have 7 minus 2, right? So you get 7 minus 2. Is that equal to 2 minus 7? Because if we were to do the commutative property of subtraction, if there was such a thing, then 7 minus 2 would equal 2 minus 7, which would have to mean that 5 would have to equal negative 5, which we know is not true. We know that's not true. So there is no commutative property of subtraction. It just doesn't work. The closest you would ever come to a commutative property of subtraction would be to rewrite that 7 minus 2 as 7 plus negative 2, because whenever you have minus a positive number, that's the same as adding a negative. So 7 plus negative 2, you could then rewrite it as negative 2 plus positive 7, which would give you the same result. You could do that, but you can't do 2 minus 7, if that makes sense. That's the closest you would ever come to a commutative property of subtraction. But in subtraction, you cannot rearrange which one's positive or negative. It just doesn't work. So commutative property works for addition. It also works for multiplication. We got the commutative property of multiplication. So when we have the commutative property of multiplication, that's saying a times b is equal to b times a. Whenever you have the commutative property of multiplication, if you have any arbitrary number a times b, it is equal to b times a. So the commutative property allows you to move numbers around in addition and multiplication to sometimes make it easy for you to solve an equation. That's how you could do that. So let's say we had 3 times 5, right? 3 times 5, well, that's equal to 5 times 3. Because, well, 3 times 5 is 15. We know 15 equals 15. If the left side equals the right side, you have a true statement. Therefore, yes, 3 times 5 does equal 5 times 3. And then, I don't know, let's say we have 19 times 10, right? 19 times 10, that would be the exact same way. If you use the commutative property, switch them around, you'll have 10 times 19. You would get the same result. So, therefore, it works with multiplication. Now, does the commutative property work with division? Let's find out. Let's find out here. So let's say you have 6 divided by 3, right? You have 6 divided by 3. We're asking, is that the same? Is that equal to 3 divided by 6? Is 6 divided by 3 equal to 3 divided by 6? Well, 6 divided by 3, well, that's 2. 3 divided by 6, that's 1/2. 2 definitely does not equal 1/2. So the commutative property does not work with division. The closest thing you could ever come to doing that is if you have that 6 divided by 3. We remember when you divide, you multiply by the reciprocal. So you'd have 6 times 1/3 if you're dividing by 3. You could now rearrange it to have 1/3 times 6. You would get the same result that way. That's the closest you're ever going to come to a commutative property of division, but you simply cannot switch the 3 and the 6 around, though, with the commutative property, or at all, because you're not going to get the same result. The commutative property only works if you get the same result, if you switch the places around. So the commutative property only works for addition and multiplication. Now, we've talked about the commutative property when the numbers commute, when they move around. That's how you remember that. So now we're about to talk about the associative property. Let me move this over some so I can spell it out better. Associative property of addition. So we're going to talk about first the associative property of addition. So let's say here I have A plus, in parentheses, B plus C. Any number A plus, in parentheses, B plus C, those numbers, that's the same thing as, in parentheses, A plus B plus outside the parentheses C. So that's the same as any arbitrary number plus 2 numbers in parentheses is equal to the other 2 numbers in parentheses plus another arbitrary number. For example, let's say I have 1 plus, in parentheses, 2 plus 3, right? In parentheses, I have 1 plus 2 plus 3. Well, that should equal, in parentheses, 1 plus 2, then outside the parentheses, 3. Well, let's do the math and prove it. We would, of course, on the left side, do your parentheses first. You'll have 1 plus, what is 2 plus 3? That's 5. We'll set that equal to, what is the parentheses here? 1 plus 2, that's 3. You'd have 3 plus 3. 1 plus 5, that's 6. 3 plus 3 is 6, so yeah, we have a true statement. 6 equals 6. So with addition, you can place if it's the whole problem is addition, the whole problem's got to be, okay? The entire problem's got to be addition. If it is, it doesn't matter where you place the parentheses. Let's do another one like it here. Let's say we have 19 plus 37. Let's do this. 19 plus, in parentheses, 37 plus 56. Well, that should be equal to, in parentheses, 19 plus 37 plus outside the parentheses 56. Those should be equal. Okay, so of course, let's do the math and prove it here. You have 19 plus what's inside the parentheses. What is 37 plus 56? Let's see, 37 plus 6 is 43. It'd be 93. So you have 19 plus 93 would be equal to Now it was 19 plus 37 on the right hand side. 19 plus 37 is 56. You'd have 56 plus 56. Left hand side, 19 plus 93, that's 112, which is equal to 56 plus 56, 112. So yes, you get a true statement. 112 does equal 112, so therefore the associative property holds with this problem. So as long as your problem is straight addition, you can use the associative property and move the parentheses around however you wish, and you'll get the same result each time. Now, of course, it's also asked a lot, does the associative property work with subtraction? No, and I'll show you why. Let's say you have 6 minus 2, 6 minus, in parentheses, 2 minus 3, right? Is that the same as, in parentheses, 6 minus 2 minus 3? Is that the same? Well, let's go on the left-hand side here. You'll have 6 minus what is in parentheses. 2 minus 3 is negative 1. So you'd have 6 minus negative 1 equal to what's in parentheses on the right-hand side. 6 minus 2, that's 4 minus 3. Well, you'd have 6 minus negative 1 on the left-hand side. That's the same as 6 plus 1. You'd be setting that equal to 4 minus 3. 6 plus 1 is 7. 4 minus 3 is 1. We know 7 does not equal 1. So this right here, even one counterexample throws the whole assumption out that there's an associative property of subtraction. This proves that the associative property does not work for subtraction. It only works for addition and what we're about to do here, multiplication. It doesn't work for division, and we'll also prove that. But let's talk about the associative property of multiplication. Multiplication, right? We're going to do the associative property now of multiplication, which is saying that if you have A, any number A times, in parentheses, B times C, that's the same as taking that number, in parentheses, A times B times the number outside parentheses, C. So that also says that just like addition with multiplication, if it's straight multiplication, it does not matter the order you put the parentheses in. So let's say, for example, we have 5 times, in parentheses, 2 times 3. Well, we're going to prove that that's equal to, in parentheses, 5 times 2 times the parentheses outside, times 3 outside the parentheses. So on the left-hand side, we'll do 5 times, what is in parentheses? 2 times 3 is 6. Well, 5 times 6, set that equal to what is 5 times 2? That's 10 times 3. Well, what's 5 times 6? That's 30. What is 10 times 3? It's also 30. We have a true statement here, so therefore the associative property holds with the multiplication. So if it's pure multiplication or pure addition, the associative property holds. Let's do one more example for good measure here. Let's say we have 7 times, in parentheses, 3 times 5, right? We'll set that equal to, in parentheses, 7 times 3 times the 5 outside of parentheses. Okay, now, of course, we're going to work on the left-hand side. 7 times what's inside the parentheses? 3 times 5, that'd be 7 times 15. We would set that equal to what's in parentheses? 7 times 3, that'd be 21 times 5. Well, what is 15 times 7? Well, that's going to be 105. 21 times 5, that's also 105. So yes, the associative property holds for this problem. So this proves that if you're doing it with multiplication, it also does not matter the order in which you move the parentheses around if it's straight multiplication. It has to be either straight multiplication or addition. It does not work with subtraction or division, as we're about to prove, because let's say with division, let's say you have something like 6 divided by, in parentheses, 2 divided by 3. You're going to try to set that equal to, in parentheses, 6 divided by 2, and then divided by 3 outside the parentheses. Okay, well, of course, on the left side, you'll have 6 divided by, what is 2 divided by 3? Well, that's going to be 2/3. 6 divided by 2/3, which would equal, what is 6 divided by 2 in parentheses? That's 3. That'd be 3 divided by 3. What is 6 divided by 2/3? Remember, when we divide by a fraction, we multiply by the reciprocal. So that'd be 6 times 3/2. We would be setting that equal to 3 divided by 3. Well, we know 2 cancels between the 6 and 2. If you divide 6 by 2, you'll get 3. So you would end up with 3 times 3 equal to 3 divided by 3, which would then, that'd be like saying 9 equals 1. Well, we know for a fact 9 does not equal 1. So this is one counterexample that will prove the associative property does not work for division. It just doesn't work. So the commutative property, remember it as the numbers commute. They move around. The commutative property, you can do it if the problem is either pure addition or pure multiplication. Then the associative property deals with parentheses. That's what the associative property deals with, is parentheses. So we've covered those so far. And the associative property also, like the commutative, only works if it's pure addition or pure multiplication. Well, let's cover a few other properties here. We have what is called the additive identity. We have the additive identity, which states that some arbitrary number, a, plus 0 will give you back that number a. We've covered this in basic, but just a real quick review. Let's say I have 7 plus 0. Any number plus 0 is that number. So that's the additive identity. Any number plus 0 equals that number back. I don't think we need to spend a bunch of time on that. I think that one's pretty self-explanatory. Any number plus 0 is, in fact, the number back. Now let's talk about the multiplicative identity. Let's address the multiplicative identity. The multiplicative identity says if you have any arbitrary number, we'll call it a, times 1, you'll get that arbitrary number back. So let's say I have 7 times 1. Well, any number times 1 is that same number back. So that's the multiplicative identity. I also don't think we need to spend much time on that. That's pretty straightforward. Now, there is one more I'd like to talk about, which also is going to seem laughable, but it needs to be covered. The multiplicative property of 0. The multiplicative property of 0. So let's say you have any arbitrary number times 0, you'll get 0. So let's say I take 7 times 0, I'll get 0. Because any number times 0 is 0. So that's the multiplicative property of 0. I don't think we also need to spend a bunch of time on that. Alright. So let's do a few problems here where we're going to simplify the expression. Let's say you have this in parentheses. You have m plus 8 plus 4. We're going to simplify the expression. We notice this is an addition problem. They're using the associative property. In fact, what you could do, since it's all addition and it doesn't matter, you can go ahead and get rid of the parentheses. You really don't need the parentheses. You just have m plus 8 plus 4. Now, when you simplify algebraic equations such as this, what you have to do is called collect like terms. That means if I had several variable expressions with the letter m, I would add those up, and then just the plain numbers, which are called constants, I would add those up. So m is by itself. M stands alone, but 8 plus 4 is 12. So the answer I would get is m plus 12. Because we only have one variable term, but we have two constant terms. 8 plus 4, that's 12. So you would get m plus 12. How about you would get 15 here plus the quantity of 12 plus a. 15 plus the quantity of 12 plus a. Well, since this is a straightforward addition problem and it doesn't matter what order you put the parentheses in, you really don't need the parentheses. So you can just do 15 plus 12 plus a. Alright? Well, we notice there's only one variable term. It stands by itself. We can use the commutative property to write the a term first. Now, what's 15 plus 12? That'd be 27. So you would just get a plus 27. Or you could write 27 plus a, whatever tickles your fancy. It doesn't really matter. By the commutative property, they're the same thing. So you just collect the like terms by add up all the terms that have a variable. In this case, there's only one term in the equation that has a variable, so that stands alone. Then add up your two constants, which are your regular numbers. And you have your expression there. You have the expression simplified. Alright, let's see here. You have 21 plus, in parentheses, k plus 16, right? Well, we're going to do a couple switches here. First, again, this is a regular addition problem. So, in all honesty, we really don't need the parentheses. We can just get rid of them. You'll have 21 plus k plus 16. Now, if you want, we can use the commutative property. We can switch places with k and 21. You also have k plus 21 plus 16. By the commutative property, you can move the numbers around. And now you have the variable term by itself, which would just still be k, but you would add up the two constant terms, the numbers. So 21 plus 16, that's 37. So the answer you would get is k plus 37. That would be the answer to that. So yes, first I got rid of the parentheses. By the associative property, I could do that. Then I switched places with k and 21 by the commutative property of addition. Then I just simply added up the two constant terms, and you got k plus 37. So now I want to do some multiplication ones. All right. Say you have 6 times, 6 times the quantity of y times 2. Well, Again, this is a straightforward multiplication problem. You honestly don't need the parentheses, so you'll have 6 times y times 2. So if you just work from left to right, 6 times y is 6y times 2. 6y times 2, well, that's 12y. You would just get 12y. So pretty simple here with the multiplication. You really also didn't need the parentheses because it's a straightforward multiplication problem. Alright, let's say you have 7 times, in parentheses, d times 4. So we have 7 times, in parentheses, d times 4. Well, we don't need the parentheses since it's a straightforward multiplication problem. You'll just take 7 times d times 4. Now we just work from left to right. 7 times d, well, that's just 7d times 4. 7d times 4, well, that's going to be 28d. You would just get 28d then. Because whenever you multiply a constant by a variable, that's all it is. You're multiplying the constant and the variable, so you would get 28d, if that makes sense. I feel like we should do one more. Okay. So you have, in parentheses, 3 times w times 5. 3 times w times 5. Well, again, this whole problem is all multiplication. You don't need the parentheses. So by the associative property, you can get rid of them. So then you'd just be left with 3 times w times 5. Well, now you just work from left to right. 3 times w, that's 3w. All that times 5. Whenever you have a variable term times a constant, you just simply multiply the constants, and you would get 15w. The variable power doesn't change. You would just get 15w. So that would be your answer. So we saw some of these associative and commutative rules with variables. And oftentimes, if a straightforward addition or multiplication, you don't need the parentheses. You can get rid of it and not overcomplicate things and just do a straightforward addition or straightforward multiplication. So that's really all there was to this lesson. The very next lesson is going to be covering variables and equations. We will deal a little bit more with some variables and also form a little bit more of some expressions from English sentences. So I hope everyone has a good night. Take care.